An agent demo can look brilliant and still fail the first production question. What exactly happened? Who approved the risky part? And what checked the result before anything changed? This is fluid coding and AI. Today we are looking at step functions as the control path around agents, not as another agent framework. The practical question is simple. If an agent classifies a case, plans an action, or calls a tool, can the surrounding system still behave like a production workflow? That means deterministic data collection, explicit model calls, retries, approvals, parallel review, failure handling, and an execution record someone can inspect after the fact. If the answer is no, the agent may be useful, but the system is not ready for risky automation. Step functions matters here because it creates an explicit workflow boundary. AWS describes it as a service for coordinating application components and services through state machines. Those state machines can use task states, choice states, weights, maps, and parallel branches. For agents, that means the process can be visible and bounded instead of hidden inside one autonomous loop. The agent handles uncertainty. The workflow owns the path. For audit-heavy work, standard workflows are the safer default. AWS records execution details for standard workflows, and the console can show each executed state, including the state name, resource, and status. There are limits. Standard execution history is retained for 90 days after the execution closes, and there is a 25,000 event history limit. So step functions gives you a visible record, but long-term audit still needs durable storage. A strong workflow does not start by asking the model everything. It starts with deterministic steps. Collect the request, account state, policy rules, recent events, available actions, and authorization scope. Then normalize and validate required fields, timestamps, schemas, and payload size. If the request is incomplete or outside scope, fail early. That is not less intelligent. It is how you keep the uncertain part small enough to control. The model or agent step should have a narrow job: classify the case, propose a plan, estimate risk, cite supporting evidence, and return structured output. Step functions can invoke Amazon Bedrock models directly through its optimized Bedrock integration. AWS also notes an important boundary. Step functions does not validate the body passed to invoke model. So validation belongs before and after the model, not inside wishful thinking about the prompt. Agent workflows also hit boring limits quickly. The optimized Bedrock integration has a 256 kilobyte payload limit when using the body field. That matters because retrieved documents, long case histories, and model outputs can get large. The safer pattern is to store bulky evidence in S3 and pass references through the workflow. The state machine should carry the control data, not every byte of context. Human in the loop should not mean sending a vague message and hoping someone remembers what happened. AWS documents a callback pattern where the workflow pauses with a task token, sends the approval context to another service, and resumes when that token returns with an approval or rejection. That turns review into a real execution state. The approver sees the proposed action, evidence, risk reason, and model output before the workflow continues. Parallel agents are useful when their jobs are different. A step function's parallel state can run branches concurrently and wait until all branches finish before moving on. In this design, one branch can review policy and compliance. Another can review operational impact or customer context. The important part is structure. Each branch should return a defined output. This is not two agents debating forever. It is two specialist checks that the workflow can merge. There is a sharp edge here. In step functions, if one parallel branch has an unhandled error or reaches a fail state, the whole parallel state fails from the workflow perspective. AWS also notes that Lambda functions already invoked by a branch can continue running, because step functions cannot forcibly stop that running code. So any branch that can trigger side effects needs idempotency, compensation, and cleanup design. The final checker is where trust becomes operational. Do not ask the same model, "Are you sure?" and call that verification. Use deterministic checks for schema, identifiers, allowed regions, policy constraints, approved amount, and required evidence. Where judgment is needed, AWS now positions agent evaluation as its own discipline, with LLM as judge evaluators, custom evaluators, and code-based Lambda evaluators in agent core evaluations. There is no public AWS scorecard for this exact architecture. Deterministic collection, an agent plan, human approval, 2 parallel agents, and a final checker. That absence matters. AWS has described evaluation methods and multi-agent capabilities, but it has not published a reproducible headline score for this whole pattern. So the honest benchmark answer is this: test your own workflow with repeated trials before trusting it with production side effects. This does not mean Step Functions replaces Bedrock's agent orchestration. Amazon Bedrock multi-agent collaboration became generally available on March 10, 2025. It uses a supervisor agent to break down requests, delegate tasks to specialists, and consolidate outputs. AWS says the supervisor can communicate with subagents in parallel. The distinction is scope. Bedrock can orchestrate agents inside the agent system. Step Functions orchestrates the external production process around it. Step Functions is not the right hammer for every agent. For a simple read-only chatbot, a prototype, or a low-risk internal assistant, this much orchestration can be unnecessary overhead. It becomes interesting when the workflow touches money, production infrastructure, customer communication, policy exceptions, or anything where engineering, security, and operations will ask for a clear control path. The more consequential the side effect, the more valuable the boundary becomes. The verdict is not that Step Functions makes agents safe by default. It does not. The useful claim is narrower and stronger. Step Functions can make the agent one controlled step inside a visible workflow. Let deterministic code collect and validate context. Let the agent classify or plan. Gate risky actions. Run specialist branches in parallel when they add different evidence. Then check the result before committing anything. That is the production shape worth testing. If this helped you think more clearly about agents, approvals, and production control, like the video and subscribe to Fluid Coding and AI. More practical AI engineering breakdowns are coming.